Ladies and gentlemen, boys and girls, welcome to another episode on the Incredible Academics YouTube channel. Guys, listen. So we're just going to continue with where we left off. Remember, this is what we had on the previous video. We came up with the formula for the compound angle identity for cosine, because remember, in grade 11 this is what you guys did. So you guys dealt with cosine of 2 alpha, the sine of 2 alpha. So this is double angles, okay? But now we are changing the we are changing things a little bit, right? We're tweaking things a little bit. Now we're dealing with compound angles, which is the cosine of alpha plus beta. So in other words, now we're summing two angles that are not homogeneous. In other words, these angles are different. So the sine of alpha plus beta, because remember, with double angles, when you've got the cosine of 2 alpha, basically you've got the cosine of alpha plus alpha. So in other words, this is still a compound angle, but because it's the special case of a compound angle, we call it double angle. Why? Because the two angles that are being added here are identical. Okay, same goes for the sine of 2 alpha. You realize that this is sine alpha plus alpha. All right, we've got two angles over there, but the difference between this and that is that here we've got heterogeneous angles, here we've got homogeneous angles. It simply means that here the angles are different, here the angles are the same. Okay, so we end up with double angles. So now we're shifting the focus from this, which is double angles, to that, which is compound angles. Okay, so we have proven that the cosine of alpha, the cosine of alpha minus beta is basically equal to cosine alpha sin beta. What am I doing? Today I'm so full of mistakes. I don't know what's going on with me. But anyway, the cosine of alpha minus beta is equal to cosine of alpha, the cosine of beta, minus, it's not minus, it's plus, because here it's minus, here we're going to say plus, and then the sine of alpha, the sine of beta. So this is the identity, you guys. This is the identity. And even if the two angles were identical, in other words, I mean, if they were identical, if we had cos alpha minus alpha, this would definitely give you, because this is the same as the cosine of 0. Yes or no? The cosine of 0. The cosine of 0 is 1. So if you were to expand this, it would give you 1. So you can still expand like this. It's probably going to give us the square identity. So cos alpha, because it's minus here, we say plus here, and then sine alpha. Okay, so what do we have? Cos squared alpha plus sine squared alpha, and what do we have? This is just 1, isn't it? That is the square identity. So yeah, that's the case where the two angles are identical. Yeah. So we need to, because obviously there's going to be cases whereby we've got cosine of alpha plus beta. So what would be the expression in this case? So that's the thing that we need to figure out. So in other words, if we don't have minus, but we've got plus. All right? So we need to figure that out. So what we can do is we can rewrite this whole thing. So the cosine of alpha minus beta. Can you see that? Okay, I mean, this is exactly the same as that, right? But now this has the form of that this time around because there's a negative in between, and we know how to expand this because we're going to use the exact same expansion that we have over there, but because this time around in place of b we've got minus b, then that means we're no longer going to substitute b. So this is the same as the cosine of alpha, cool, and then the cosine of what? The angle that's it's minus b now. So minus b, and then is it plus or minus? Yes, it's going to be plus because there's a negative here. Cool. So now look at what we have over there. Sine alpha, we're just copying whatever that's there. So that's that in place of beta, we put negative b. So sine of negative b. Okay, so we know that the cosine is going to absorb the negative, so we're just going to have cosine of alpha, cosine of beta. All right, but sine doesn't have that ability to absorb negative angles. So this negative here, it's going to jump out and replace the plus. So minus the sine of alpha and then the sine of beta. So this is the expression for that. So can you see that the only thing that changed was just the middle sign? So not much has changed actually. So here's what we can do. Now we need to figure out, okay, what is the sine of alpha minus beta? So this is the one that we need to figure out now. Any ideas? So let's figure this one out. So we're going to remember this sine and cosine are actually co-functions. Okay, they're co-functions. All right, in other words, they're just 90 degrees apart, sine and cosine. So the sine of alpha minus beta is the same as the cosine of 90 degrees minus alpha minus beta. All right, because these are co-function ratios. Okay, so we can then rearrange this whole thing in such a way that we've got the form of either alpha plus beta because we've got the expression for alpha plus beta, okay, or the expression for alpha minus beta because we've got that. Okay, so it's up to us. All right, it's up to us. So let's rearrange. What we're going to do is we're going to pick one angle from this side, from this bracket, and pair it with the 90 degrees. Okay, we can pair the 90 degrees with the alpha or the beta. The choice is yours. So we're going to say let's just have I don't know, I mean, it's going to be apparent once we have removed the brackets. All right, so now we just got a grouped two angles, 90 degrees and some other angle, alpha or beta. So let's just group 90 degrees and minus alpha. Okay, so cosine of beta plus 90 degrees minus alpha. Okay, so there we go. So now the cosine, which has got a plus, it's actually that one. Okay, and its expansion, it's like that. So we're going to have cosine of the first angle and then cosine of the second angle. So cosine of the first angle, which is beta, and then cosine of the second angle, which is 90 degrees minus alpha. And then it says minus in between, so minus. If it's plus here, then here becomes minus. Therefore, minus the sine of the first angle, which is beta, and then the sine of the second angle, which is 90 degrees minus alpha. So we're almost there, ladies and gentlemen. We're almost there. So now the cosine of 90 degrees minus alpha, what's that? What's that? So that's going to be the sine of alpha yo, and cosine of beta, it's just this cosine over there, and then minus, I'm just rearranging everything, the sine of 90 degrees minus alpha, that's going to be the cosine of alpha, and then the sine of beta. So we've got the expression for sine alpha minus beta, right? But what about sine alpha plus beta? Sine alpha plus beta. So because we came up with this one, right? Everything builds up from this. Whatever you came up with, then you can use to come up with other things. So we came up with sine alpha minus beta. So this is what we're going to use to find sine alpha plus beta. Okay? So we know that sine alpha minus beta is given by sine alpha cos beta minus what? Sine beta cos alpha. Okay, we can go back and double check. Sine alpha cos beta minus cos alpha. Sine beta is the same thing as I said. That one, these two are just swapped around, but multiplication order doesn't matter. So it's still the same thing. So we've got this. So now let's figure out what's going to be the expression for what's going to be the expression for the sine of what? Alpha plus beta. So remember, this is the same as the sine of alpha minus beta. Okay, and this becomes exactly like that. It's just that now instead of beta there, we've got what? Minus beta. Okay, so let's go right ahead and simplify. So we're copying exactly what we have over there, but in place of beta we put minus what? Minus beta. So the sine of alpha, the cosine of minus beta, and then minus, okay, because there's a minus there in the middle. So, and then minus the sine, what is beta? In place of beta, remember, we put minus b. And the cosine of alpha. Alpha is just alpha. So it's pretty much done by the look of things. Remember, cosine is going to absorb the negative, in front of the beta. So the sine of alpha, the cosine of beta, but sine is not capable, Sine doesn't have the powers to actually absorb the negative in front of the beta. So the negative is just going to multiply with the negative there, then becomes what? Plus. So plus sine beta cos alpha. We can actually start with cos alpha and then end with sine beta. Okay, so that's that, ladies and gentlemen. We've got the expression for sine alpha plus beta now. All right, so we've done all the fundamentals for compound angle identities. We know how to prove them. We started with unit circle and we did everything, so we're ready to tackle some real problems based on compound angle identities. So next time when we meet, we're definitely going to be tackling some problems which are like it's application type of problems, because right now we're just doing proofs and all that, which is very, very important, you know, for trig, right? Because these questions, they are, you know, they're most likely to come. But anyway, I hope you guys enjoyed the lesson, although this time around it was like a half lesson. Normally it goes up to, you know, 30 minutes. But you guys enjoy the rest of your day. And today's date is the 9th of January 2024. That's when the video is being recorded. And shout out.